How to Choose the Right Fuse by KayScience.com. A television, radio, and electric heater are all examples of electrical appliances which have different strength electric currents flowing through them. Because they all have an electric current flowing through them, they all need fuses. The fuse can be found in a 3-pin plug, which I'm drawing here. Here I'm drawing the cable grip which holds the 3-core cable in place. Remember, the 3-core cable consists of 3 different wires. The blue wire, which is the neutral wire, the green and yellow wire, which is the earth wire, and the brown wire, which is the live wire. And this is where the fuse is. The fuse is in the plug, so if the current is too high, the fuse melts, breaking the current. The current cannot flow through the plug, causing the appliance to turn off. Remember, the neutral wire has a potential difference of 0 volts. The earth wire is there for safety, and the live wire has a potential difference of 230 volts. Now this fuse is either going to be a 1 amp fuse, a 3 amp fuse, a 5 amp fuse, or a 13 amp fuse. Before we work on understanding which fuse should we use in an appliance, we first need to make sure we understand what a fuse truly does. This is the circuit symbol of a fuse, and this line going through the fuse represents the metal filament inside the fuse. Now if the current goes higher than the current stated on the fuse, for example 1 amp, if the current is say 1.5 amps, what happens is the metal filament melts. This diagram represents how the metal filament has melted. The circuit is now broken, so the electric current can no longer flow through the circuit. This only happens if the current goes above the maximum current stated on the fuse. It's question time. Attempt these questions to check your understanding. Let's now focus on understanding how to choose the right fuse for different domestic appliances such as a TV, radio, and electric heater. To understand which fuse an electrical appliance should be using, we need to calculate the maximum current that will flow through that electrical appliance. To do this, we need to know the power rating and the potential difference of each appliance. All of these appliances are connected to the main supply, where they all have a potential difference of 230 volts. Every appliance has a power rating, which is how much energy is transferred each second for the appliance to work. In this example, the television has a power rating of 350 watts, but this will vary depending on which television is used. And we already know the potential difference is 230 volts. And how do we calculate the current flowing through each appliance? Well, the equation is I equals P over V. That's current equals power divided by potential difference. So using this equation, I equals 350 watts divided by 230 volts. So I equals 1.52 amps. So now using this information, the question is, which fuse should be used for this television? Is it a 1 amp, 3 amp, 5 amp, or 13 amp fuse? I'll give you a moment to think about it. The answer is a 3 amp fuse, as 1.52 amps is above 1 amp, but below 3 amps. It's question time. Attempt these questions to check your understanding. In this next example, the radio has a power rating of 9 watts. And we know the potential difference is 230 volts. To figure out which fuse we need for this radio, we calculate the current. I equals 9 watts divided by 230 volts. This calculation tells us I equals 0.04 amps. This tells us the maximum normal current that should be flowing through the radio is 0.04 amps. So which fuse should we use? the 1 amp, 3 amp, 5 amp, or 13 amp fuse? I'll give you a moment to think about it. Well, the answer is a 1 amp fuse, as 0.04 amps is below 1 amp. In this example of the electric heater, you've been given the power rating of 1500 watts and a potential difference of 230 volts. It's your job to figure out which fuse should be used out of a 1 amp, 3 amp, 5 amp, and 13 amp fuse. The answers will follow. These calculations show a 13 amp fuse should be used, as 6.52 amps is the maximum current which should flow through this electric heater. This is above 5 amps but below 13 amps. Pause the video here to practice the keywords. The answers will follow. Press pause to answer the questions. The answers will follow. If stuck, just rewatch the video. Press pause to go through your answers and make any corrections to your mistakes. And don't forget to visit KayScience.com for more videos, worksheets, and quizzes at KayScience.com. And don't forget to like and subscribe.